in today's lesson, we're going to learn about the reactions involving bases with other substance. So the first type of reaction is between bases and acids. So this part we've covered in the acid part, so I will just let you to complete the first three reactions first. So please pause it and then complete your equation and then check your answer by resuming the video. So when bases react with acid, it will produce salt and water, and this type of reaction is called neutralization reaction. Okay, so according to the neutralization reaction, the first three would produce these compounds. So the first one, it would form the salt, which have the metal from the hydroxide and also the anion from the acid. So the product will be sodium sulfate with water. Okay, make sure you balance the equation and also consider whether the product, the salt formed, is soluble or insoluble. And then for the second one, again, it would have the salt would be the metal from the hydroxide or the oxide, and then the anion from the acid. So the product would be calcium chloride plus water. And two balances, and then state symbol. And the third one, okay, so it's involving organic substance. So to write the product for organic solvent, it's the same principle. Okay, so the product would be CH3COO, that's the anion, and then combined with the cation from the hydroxide, okay, and then water. So remember, group 1 salt, they are all soluble, so it doesn't really matter if it's organic or inorganic, okay, so you can still add AQ for it. Okay, so for equation 4 and 5, it gets a little bit complicated. Here we have carbon dioxide and sulfur dioxide. Okay, at the first place, you want link it to an acid, but I would like you to write these two equations next to it, so it will help you to write the equation. So carbon dioxide can dissolve in water, and it will undergo a reversible reaction to form this kind of acid. Okay, and this acid would be able to release two hydrogen ion and also one carbonate ion. So when you consider this reaction, you can actually view it as a reaction between sodium hydroxide and also this acid, and then try to write the equation. Okay, so the product gonna be sodium carbonate and again water formed. And remember, balance the equation. So similarly, sulfur dioxide would also have reaction with water, and it will form what is called sulfurous acid. Okay, so sulfuric acid can also release, each of the sulfuric acid molecule will also be able to release two hydrogen ion and one sulfide ion. So it's dibasic. And again, when you write the equation, you can consider that's a reaction between sodium hydroxide and then with the sulfurous acid. Okay, so the product gonna be sodium sulfite. Again, group 1 is all soluble plus water. Remember to balance the equation. Okay, so that's the most simple reaction between acid and base, neutralization. So my notes may look, the format of my notes may look a little bit different compared to yours, but it's got more space for me to write. Okay, and then let's move on to the second type. Second type is a reaction between base with ammonium compound. Okay, so for this type, you need to remember the general word equation. So when base react with ammonium compound, it would provide ammonia gas, water, and also a salt. So let's look at an example. So for the first equation, we have ammonium chloride react with sodium hydroxide. So according to the general word equation, so it would form a salt. So the salt would have the cation from hydroxide and the anion from the ammonium compound. Okay, so it will be sodium chloride. Okay, sodium chloride, group 1 metal, a group 1 salt, is soluble. Okay, and then it will produce ammonia gas and then water. Okay, so let's check, is it balanced? Yes, it's balanced. Okay, in order for this reaction to happen, we need to gently warm the two reactants. So we can write the condition above the arrow. So to write the ionic equation, we need to separate the ions from the ionic substance in aqueous solution. Okay, so for the first one, we could separate it as ammonium ion plus chloride ion, and then we got sodium ion, and we have hydroxide ion. Okay, so for here, to speed up the process, I didn't include the state symbol. But when you practice it, please write the state symbol because you may make mistakes if you forget the state symbol. Okay, so on the right hand side, sodium chloride will provide sodium ion, chloride ion. Okay, for ammonia, since it's a gas, it's not an ionic compound and not in aqueous solution, so we could not separate it. So again, we have NH3. And then we have water, which is a covalent compound, so it will stay as a molecule. Now we can cancel out the spectator ions that we have on both sides. So we will cancel out the chloride ion on both sides. We will cancel out the sodium ions on both sides. Then we're left with ammonium ion in aqueous state react with hydroxide ion in aqueous state, and under the condition of gentle warm, it would provide ammonia gas and also water. So that's the ionic equation. Take a look at the second example. In this case, the base is not an aqueous solution. We have calcium oxide as the base. Okay, but still it behaves the same and produce a salt and ammonia and water. So let's try to write the product. First, the salt will get the cation from the base, and then it will get the anion from the ammonium compound. So the salt gonna be calcium chloride. So for calcium chloride, since it's soluble, so we write AQ for it. And then it will form ammonia gas. and also water. Okay, now let's check whether this is balanced. We have 2 chloride ion, so we need 2 on the left hand side for ammonium chloride, and then it will release 2 ammonia gas, and then the equation is balanced. Remember the condition, we need to gently warm the 2 reactants in order for this reaction to take place. Okay, inside the box it shows the setup. Okay, I will try to let you to try to do this experiment when the normal teaching is resumed. Okay, so we put the base and ammonium salts, and it should be well mixed at the bottom of the test tube, and then we gently warm it, and then you will see a gas coming out. A gas is formed which is colorless. Okay, and this gas, which is ammonia, has a very special property that it has a really bad smell. So in chemistry, we describe this kind of smell as a pungent smell. Okay? So we would describe a pungent gas is formed. Remember, when we write observation, never mention the name. Okay, never mention the name in your observation because you haven't tested for it. Okay, so observation, just describe it's colorless and it got a pungent smell. Okay, so for some reaction, if we use a wet and red litmus paper, okay, so we may color it wet and red litmus paper, and when the gas meet the wet red and litmus paper, because ammonia is got alkaline property when it dissolving water, so it will turn the red litmus paper into blue. Okay, so if we so the bottom part, or eventually the whole thing will turn into blue. Okay, so the bottom part will turn into blue. That's due to the ammonia gas. So this is a test for ammonium ion in a compound. So it has to fulfill 2 criteria. So first, we need to warm the ammonia compound with a base. Okay, and then if a colorless pungent gas formed, and this gas would turn the wet red litmus paper blue, then it's ammonia gas. Since there are other kind of gas which have the pungent smell, but only ammonia is an alkaline gas. Okay, so by doing the test, we could show that this is ammonia, which is come from ammonium ion in the compound. Okay, so please put a star. This is an important reaction in this unit. Okay, and when we clear the ammonia gas, okay, because remember here we gently warm the reaction. So the water in the air will also turn into evaporate. Okay, so how do we get rid of those water in those evaporated water? So we need to pass it through what's called a drying agent. So on your notes, you need to make a correction. So in order to dry the ammonia gas formed, we can only use the anhydrous calcium oxide, okay, not the calcium chloride. Please cross it out. And the reason for that, we're gonna learn in the next lesson. We have a lesson just study the drying agents later on. Okay, so after passing through the anhydrous calcium oxide, we will get rid of all the water vapor and we will get the dried ammonia gas at the end. Okay, so that's a way for collecting dry ammonia gas. So that's a second type of reaction, base with ammonium compounds. Here is a video showing the demonstration between ammonium compound and a base.
Put 1 spatula measure of solid ammonium chloride and 2 spatula measures of solid calcium hydroxide in a mortar. Mix the solids well by using a pestle. Put the mixture into a test tube. Warm the mixture gently. Hold a piece of moist red litmus paper in a stream of the gas given off. Record your observations. The moist red litmus paper becomes blue.
Let's move on to the third type of reaction, sodium hydroxide with metal ions in aqueous solution. Okay, so sodium hydroxide, okay, although we're going to learn in detail in next unit, but here I want you to draw down sodium hydroxide is a strong alkaline. So what do we mean by strong? Okay, so strong alkaline means the reaction gonna go one way. So we can assume that sodium hydroxide would completely goes in this direction, and then it will form sodium ion and hydroxide ion. So there will be no sodium hydroxide left in the solution. Okay, all turn into sodium ion and hydroxide ion. And then the hydroxide ion would react with all kinds of metal cations and form the precipitate. So that's a key reaction in this part. Okay, so let's take a look at the first example. So first example, we have calcium as a metal ion. So calcium will react with a hydroxide ion, which comes from sodium hydroxide. Okay, so what do we mean? Calcium ion react with hydroxide. We can use an example. Okay, so for example, if we have calcium, an aqueous solution with calcium ion in it, an easy example would be calcium nitrate, because all nitrate ions are soluble. Nitrate salt are soluble. Okay, so hence calcium nitrate solution, okay, is a good example which contains calcium ion. And then we will have hydroxide that comes from sodium hydroxide, which is also a type of solution. So when we put these two kinds of solutions together, it will form a salt and also a precipitate. Okay, so a salt would be sodium nitrate, and also the precipitate, which is gonna be calcium calcium hydroxide. Okay, so sodium nitrate again, because in nitrate salt is soluble, and calcium hydroxide here we should only put solid. Okay, later I will explain why we only put this solid sign here. But let's turn this equation, balance this equation first and turn it into an ionic equation. Okay, so if we separate the ionic solution and cancel out the spectator ions, we will be able to get the ionic solution, which is 1 calcium ion react with 2 hydroxide ion and produce 1 calcium hydroxide precipitate. Okay, so I want you to draw down. Although we say calcium hydroxide is slightly soluble in water, and if we have calcium hydroxide dissolving in water, we can either write solid or aqueous. Okay, both of them can be correct. But in this case, remember, we have sodium hydroxide as a reactant. Okay, so the solution is not water anymore. It's not pH equals 7 solution. Okay, so the solution is alkaline. That means in alkaline condition, calcium hydroxide will not be soluble anymore. That's why we need to write solid, okay, for the precipitate, not aqueous for calcium hydroxide. Okay, so please write this down. Calcium hydroxide only soluble in water, not in alkaline solution. Okay, so if we apply the same principle, we can fill in the rest of the equation. Please pause the video now, fill in the equation on your own, and then check your answer. Okay, so for magnesium, okay, the product gonna be magnesium hydroxide, which is also the precipitate. We need 2 hydroxide ion. And then the third one, aluminium hydroxide precipitate. And then next we have zinc hydroxide. Then we have iron 2 hydroxide. And then we have iron 3 hydroxide. And then we have lead 2 hydroxide. Finally, we have copper 2 hydroxide. Okay, so among all these precipitates, most of them are white in color. Okay, so the first one, calcium hydroxide, magnesium hydroxide, aluminium hydroxide, zinc hydroxide, and also lead 2 hydroxide. They're all white in color. So there are 3 special cases that you need to remember. For iron 2 hydroxide, iron 2 iron got green color, so the precipitate gonna be in green. Iron 3 hydroxide, iron 3, you can describe yellow or reddish brown in this case. I use brown, okay, reddish brown. Okay, so you can draw the precipitates. And then for copper 2 hydroxide, copper 2 ion got a pale blue color. So the precipitate gonna be pale blue. Okay, so those metal cations, when they react with hydroxide, they're gonna form precipitates. However, some of them, when they are further, when the test tube, when we add more excess sodium hydroxide into the test tubes, some of the precipitates will actually redissolve. Okay, there are 3 special cases that are gonna be able to redissolve in excess sodium hydroxide solution. Okay, they are aluminium hydroxide, lead-2 hydroxide, and also zinc hydroxide. And what's going to happen is that aluminium hydroxide precipitate would further react with a hydroxide ion in the solution, and it will form a complex ion, okay, which will have this formula AlOH4 and then minus. Okay, so why we got a minus charge here, right? Minus charge here. That's because the overall charge need to be balanced. On the left side, we have one hydroxide ion which carries one minus charge. So on the right hand side, the charge also need to be balanced. So the overall ion should have a negative charge. And also you can refer as this. One aluminium ion will carry 3 plus, and we have 4 hydroxide ion, which in total carries 4 negative charge. So overall, the ion would carry 1 minus charge. Okay, 1 minus charge. So that's a complex ion, and this complex ion is soluble in water. So the solution would turn into colorless eventually. And this ion is called tetrahydroxyl aluminate ion solution. Okay, so how to name the complex ion in grade 12, we're going to have a unit to learn about this. So for now, just write down the name, okay? No need to remember at this stage. Okay, so similarly for lead-2 hydroxide, okay, the hydroxide ion would further react with the precipitate and produce a complex ion, which got this formula. Again, it combined with 4 hydroxide ion, and it should carry overall 2 minus charge, and is soluble in water, so the solution would turn colorless. And for this one, this complex ion is called tetrahydroxyl plumbate ion. Okay, so why is this? Okay, aluminate stands for aluminium, and we got a different name for lead. Okay, lead sometimes can be called plumbum. That's why for its complex ion, we call it plumbate ion. Okay, and then for zinc hydroxide, again, it will form a complex ion which 4 hydroxide ion combined with it, and again overall it will carry 2 minus charge and soluble in water and form a colorless solution. And for this one, the complex ion gonna be named as tetrahydroxyl zincate ion. Okay. So that's for this type of reaction. And for the 3 special cases here, we give you a hint how to remember them. So we have lead, we have zinc, we have A for aluminium. Okay, so remember these 3 special cases.
In this experiment, you are going to investigate the effect of dilute solutions of alkalis on indicators, reaction of dilute solutions of alkalis with metal ions, and reaction of ammonium compound with calcium hydroxide. Pour 4 cubic centimetres of dilute sodium hydroxide solution into each of 3 test tubes. Add 2 drops of litmus solution methyl orange and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute sodium hydroxide solution appears as blue. Methyl orange in dilute sodium hydroxide solution appears as yellow. Phenolphthalein in dilute sodium hydroxide solution appears as red. Pour 4 cubic centimetres of dilute aqueous ammonia into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute aqueous ammonia appears as blue. Methyl orange in dilute aqueous ammonia appears as yellow. Phenolphthalein in dilute aqueous ammonia appears as red. Pour 2 cubic centimetres of aluminium ion solution, calcium ion solution, lead 2 ion solution, magnesium ion solution, iron 2 ion solution, iron 3 ion solution, copper 2 ion solution and zinc ion solution into 8 test tubes separately. Add a few drops of dilute sodium hydroxide solution to the aluminium ion solution. Shake the mixture. Continue adding sodium hydroxide solution until no further observable changes. Repeat the above process by using the other 7 metal ion solutions. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in calcium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in lead 2 ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in calcium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in lead 2 ion solution. White precipitate formed in lead 2 ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Green precipitate formed in iron 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Reddish-brown precipitate formed in iron 3 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Blue precipitate formed in copper 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution.
And then we can move on to the last type of reaction, ammonia with metal ions in aqueous solution. Okay, similarly, but a little bit different to type 3. Okay, so for this one, we have ammonia. Ammonia gas, unlike sodium hydroxide, which is a strong base, ammonia gas is a weak alkaline. When we say weak alkaline, when it dissolves in water, we use this reversible sign to represent it. That means it only partially dissociates to form hydroxide ion. So not only a small amount of hydroxide ion is produced. Okay, and the reaction would go forward and also it will go backwards, so only small amount of hydroxide will be found in the solution, and this small amount of hydroxide would react with a metal cation to form the precipitate. So again, the key reaction for this part is this one. But unlike the one that mentioned in type 3, the third reaction, calcium is a special case and you need to draw it down. Okay, so put a star here. Since there only a small amount of hydroxide ion in this. Okay, so let's say only very small amounts. So it only form a small amount of calcium hydroxide, and we know calcium hydroxide is slightly soluble in water. So we actually consider there's no reaction here. Okay, so it will be no precipitate formed. So we don't write the equation. Okay, we don't write the product here. And then for the next of them, it will be the same as the previous one. So it will form magnesium hydroxide as a precipitate. And then we got aluminium hydroxide as a precipitate. We got zinc hydroxide as a precipitate. Iron 2 hydroxide as a precipitate. Iron 3 hydroxide as a precipitate. Lead 2 hydroxide as a precipitate. And finally, copper 2 hydroxide as a precipitate. So again, for most of them, they are white in color. Okay, so magnesium hydroxide again white, aluminium hydroxide white, zinc hydroxide white in color, and then lead 2 hydroxide white in color. And the 3 special cases remain the same. We got iron 2 hydroxide, which is green in color. We have iron 3 hydroxide, which is reddish brown in color. And we also have copper 2 hydroxide, which got a pale blue color. Okay, so simple and easy. Just remember the special case. And again, for this one, there are two special cases that you need to remember. Okay, so there are two types of metal hydroxide that are going to redissolve in excess ammonia solution. Okay, excess ammonia solution. Okay, so the complex ion formed going to take the ammonia, not the hydroxide anymore, because only small amount of hydroxide is in the solution. Okay, the concentration, okay, the term that we're gonna learn later on, means there are only small amount in the solution, so not be able to form the complex ion. So it will be the ammonia molecule which combine with the precipitate to form the soluble complex ion. Okay, so for the first special case, we got zinc hydroxide. It will form a soluble complex ion which got this formula. It would combine with 4 ammonia molecule. Okay, because ammonia molecule itself is neutral, and we got zinc ion which carries 2 plus charge, so overall the complex ion will carry 2 plus charge, and then it will release the hydroxide ion. Remember, your equation must always be balanced. Okay, always be balanced. Okay, so for this one, the soluble solution form the soluble complex dissolving solution to form a colorless solution as well. Okay, and to name this complex ion is called tetroamine zinc ion. Okay, that's the first special case. And then the second special case is for copper hydroxide. Copper hydroxide, again, it will combine with 4 ammonia molecule to form a complex ion which has this formula. Okay, ammonia molecule carries no charge, but copper 2 ion carries 2 plus. So overall, it will have 2 plus charge, and then it will release the hydroxide ion back to the solution. And for this one, it has a color. Okay, so the solution it formed would be deep blue in color. Deep blue in color, and it's due to this complex ion. Okay, and for this ion, we name it as tetroamine copper 2 ion. Okay, so for this one, we also got a way to help you to remember. Okay, so zinc and copper, C for copper. So please do use zinc to help you to remember these two special cases. And also, don't mix it up with the third reaction. Okay, sodium hydroxide with metal ions in aqueous solution. And I would attach the videos after my explanation, and I would try to let you to do this experiment when we go back to school and resume our normal teaching. And I would say this is gonna be one of the unforgettable experiments that in your grade 10. So please look forward to it.
Replace dilute sodium hydroxide solution by dilute aqueous ammonia and repeat the experiment. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. No precipitate formed in calcium ion solution. White precipitate formed in lead-2 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Green precipitate formed in iron-2 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Reddish-brown precipitate formed in iron-3 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Blue precipitate formed in copper-2 ion solution. The precipitate dissolves in excess dilute aqueous ammonia. White precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute aqueous ammonia.